One of the most important skills you're going to need to know is how to take the derivative in calculus. Now, in these series of videos, what we're doing is just looking at key examples to help you remember how to do that using the power rule. Okay. So now in this second example, we're going to look at how to find the derivative if your function is defined as y is equals to 2 times x to the exponent of 5 minus 6 times x to the exponent negative 7. Okay, let's see how this works. As stated in the previous video, if you're doing the CAPS curriculum, the only thing that we really need to do, right, is to know the power rule, right? And now the power rule is a differentiation technique, right, which helps us to do something called term-by-term differentiation, okay? And now what we mean by term-by-term differentiation is that the power rule says that if our terms, right, or our function is actually made up of a series of terms, okay, and those terms are in the form a times x to the exponent n, right, then the derivative, right, is just a times n times x to the exponent n minus 1, okay? So in short, what we're really doing is that we're taking this coefficient, right, and multiplying it by the exponent, right? And then as soon as we're done with that, we're reducing that exponent by a value of 1. Okay, so now let's see how that's going to work in our given example, right? So we are looking at y is equals to 2 times x to the exponent of 5 minus 6 times x to the exponent negative 7. Okay? This is a little bit more complex compared to the example that we just did, right? But it's still the same principle, right? We still have two terms, okay? So there's the first term, 2 times x to the exponent of 5, okay? And there's the second term, 6 times x to the exponent negative 7, okay? Now, these two terms are already in the form a times x to the exponent of n. Right, so then we can take the derivative of this function by simply applying the power rule. Okay. So now because we are ready to actually take the derivative, we need to use notation that actually states that what's going to follow now is the derivative function. Right. Now, because our function is defined as y, right, that notation is going to be dy by dx. Okay. So now what has to follow now is the actual derivative, right? So we actually have to start differentiating here. Okay. So for the first term, okay, so our term in blue, that's going to differentiate into 2, right, times 5, okay? And then we're going to have x to the exponent 5 minus 1, right? We still have our minus sign, okay? Now let's go for the second term. Okay, that's going to differentiate into 6 times negative 7, okay? And then we have x to the exponent negative 7 minus 1, okay? So then simplifying, we have that dy by dx, that's equals to 2 times 5 is 10, okay, times x to an exponent of 4 now, okay, and then we have minus 6 times negative 7, right, that's going to give us negative 42, right, so we're going to use a bracket because we have this minus sign here on the outside, okay, so we have negative 42 times x, so our new exponent is now negative 8. Okay, we can even do another further simplification over here, and that simplification is just going to be the distribution of this negative right into the bracket. Okay, so when we do that, we can write as a final step that our derivative function, right, dy by dx, is going to be given by the expression 10 times x to the exponent of 4 plus 42 times x to the exponent of negative 8. Okay, and you can leave the answer like that, or if you want to, you can rewrite it again by just moving this base x to the exponent of negative 8 right to your denominator. Basically just writing it as a positive exponent. Right,